Good afternoon, Frank here with Eric, and we are working on a Polarna M6 today. At issue is the drive hub on this Polarna. If you can take a listen, there is something going on in the back end here, and we want to take it apart to diagnose and see if we can make some repairs. Can hear there's quite a bit of chatter going on in there, and there's planetary gears inside of that hub, and so not certain exactly what is happening there, but we are going to take it apart and hopefully something obvious will reveal itself. So to start with, things that you need to be concerned about is make sure that the bike is in a stable position for working on it, that it will not fall over on you and potentially cause injury in that regard. We want to make sure that the power is turned off on the bike so that there is no power from the battery, the controls to the rear hub. And then the next step is to disconnect the rear hub drive motor from the rest of the control system by pulling out that disconnect, that quick disconnect there. So next steps, there are a couple of zip ties in order to free the electrical wiring. So those will need to be able to be cut and pull the electrical harness away from the bike frame. Okay, next steps are we are going to pull the fender off. In order to give us some room to work here, we'll pull the derailleur off and then the brake mechanism on the opposite side. For those of you that are new to the Polarna bike, it is a all-metric hardware bike, so you will need to use metric wrenches and metric tools on that front. So these are flathead cap screws that secure this hub assembly together. And flathead cap screws are known because there's so much surface bearing area between the screw head and the mating surface. They often are very difficult to remove. Plus, there may very well be Loctite securing this together, so we're unable to just use a screwdriver to remove the screws. So we're going to use a impact screw gun to hopefully be able to break these free. And that popped right out. So, and there is blue Loctite all over that. So in all likelihood, you will have a very challenging time trying to remove these screws using a handheld screwdriver, and will in all likelihood need to use either a hammer impact or an electric impact such as this. And you want to make sure that it's seated so you do not ruin the screw head. So yeah, double whammy of being a flat head cap screw as well as having Loctite on it. Okay, so right now we are trying to remove the cassette in order to be able to get to the innards of the electric drive. There is a nut that is securing all of this together. And actually, when we started, that nut was seated below the surface of the smallest gear on the cassette. And so what we've done is we're putting a pair of needle nose pliers on that nut and then rotating it around the fixed axle. And as that rotates around the axle, it is backing itself out. And so now it's backed off enough that I can get my fingers on it. And we should be able to manually unscrew this the rest of the way. Okay, what I'm going to do here is pull off this axle nut and see if the axle itself, the threaded portion of the axle, will slide through. So how about that? So we have all sorts of silicone. We've got a shim set. And I'm trying to inspect these planetary gears, these nylon or engineered plastic planetary gears, and there is.
Oh, he Delran?
Oh, there it is. I'm not seeing any tooth damage. I mean, there is quite a bit of play there. There is some I mean, I can feel it. I can't really. To me, based on what I'm hearing or what I'm seeing right now, that my suspicion is that that's where all that noise is coming from, because everything else is rigid. If you follow.
From those being loose.
Yeah. Because it's, you know, it, as we sat there and spun it back and forth, it was kind of like a backlashy sound to me. And just, I mean, if you can see even on the axis of the axle of this gear, you know, it's just flopping around all over the place. Yeah, I don't. So yeah, upon disassembly and inspection of this drive assembly, we're not seeing any sort of tooth damage at all on either the ring gear here, the metal gear there, or the shaft gear. The planetary gears have quite a bit of movement in them. They don't appear to have a very tight fit up. Don't know how they are supposed to be, but based on the movement, it's my judgment that is where all of the motor noise is coming from. All of the noise in the axle assembly is coming from is this looseness of the planetary gears. I think if I get a gear puller, we can try to pull from the top. Let's do that rather than try to drive all the way through. Let's see if we can pull the top of this off with the planetary gears. Let's see if this gets it to let go. I can feel it moving. And all of a sudden there is a whole lot of okay. So that's where all the movement is coming from. Yeah, the snap ring is doing its job. And there's just a whole lot of end play there. Again, I don't know the design intent, but with all of this end play in there, to me it's as though this axle, which was put in there and then I don't know how that. I'm going to pull one of these planetary gears off and see what. Oh yeah, there's no radial play. All of it is end play back and forth along the axis of that shaft. That's where all that slop is coming from. And I'm wondering, oh, look at this. I am curious now. Okay, the thickness of this snap ring is about 20 thousandths, give or take. Then the snap ring groove is 50 thousandths. There is so much, that snap ring can move so much along that axis that it's just letting that whole bearing float back and forth in there. So the curiosity that I have now is whether the groove for the snap ring is maybe machined too wide. So this is 47 thou. Yeah, because there's basically there's basically 20 thousandths of play between that snap ring and the top of the bearing, which you can feel / see that. So how do we take that? How do we take that space up? I mean, I can see if we can get some shims in the same way that they had shims here. Just like these shim washers that went on the front axle, we need to do the same thing and take up about
15,000.
Yep, basically take up that 15 to 20 thousandths on the back side. And then once that's taken up, then all that rattling back and forth is going to disappear, and it's going to tighten up, and once it's tight, we won't hear any of that chatter. So the question really becomes, at this point in my mind's eye,
You have a really thin washer.
yep, that's what I'm saying. Basically a shim. Basically, just like these shim washers that went on the front axle, we need to do the same thing and take up about
15,000.
Yep, basically take up that 15 to 20 thousandths on the back side. And then once that's taken up, then all that rattling back and forth is going to disappear, and it's going to tighten up, and once it's tight, we won't hear any of that chatter. So let's say 325-ish.
No, 3/8.
That'll be for the inside hole. It's kind of close. Here we go. This is the one. How about that? Has been used before, so that's probably why it's the right one, right? And then what do we want to do for the outside? We want to go maybe a 1/2 inch. That'll give plenty. That's close. So we'll stay with these two. There we go. Very good. Try to find about center. Perfect. There's one. Those look suitable. Oh yeah. There's no more axial movement on that gear compared to that one. You know, before we had it getting close to 20 thousandths worth of radial or axial movement on that, and now it's, I mean, it spins freely, but there's no end play. Okay. It is slowly moving down.
Gears,
They still have clearance before they engage. But yep, good call. How do we know if... Okay, that one's lined up. Oh, that one looks lined up. Yep, I think we're good to go to continue. Yep, so the teeth are meshed, so that's good. And now we gotta keep this guy from wanting to pop out. And looks pretty, I mean, by eye it's lined up, which that doesn't really mean anything because it's such a tight fit that, oops. Okay, looks like it's key's still in there, it didn't fall out. There's still a little bit of end play in there now for some reason. I don't know what changed. It's definitely tighter than it was. Okay. So these went in next, I believe. Okay, and right now, as a refresher, this drive motor was taken apart to investigate a gear noise that was coming out of the planetary gear mechanism here. We have I have another Polarna M6 identical bike that the entire rear drive wheel is completely silent. There's no noise at all. This bike had a lot of noise in the gear teeth, so we took it apart to figure out what was wrong, see if we could identify what was wrong. And what we came across with was there was significant axial play in these planetary gears around the spline. There was just a whole lot of chatter in there. And so in order to try to take some of that slack up, we totally disassembled this from the motor and ended up making some brass shim stock washers to take up the space between the sealed bearing that's pressed into this gear and the retaining ring that holds this into place. That significantly reduced the amount of axial play in there, and the hope is that once this is all reassembled, that that noise will either be significantly reduced or totally eliminated. We will see how that goes. So in order to get this going, as far as putting it back together, this housing was sealed with a gasket sealer to keep out the weather, the water, and sleet, snow, rain, etc. So when we reassemble this, we're going to put a little bit back in there, and I need to, oh, I got some left over here that I thought I'd gotten it all out, but I did not. So let me get that. I'm going to actually go grab a little bit of acetone and wipe that off. I wiped that off, but I didn't do the other one. My bad. Yeah, all kinds of crud coming off. That's much better, more better. There we go. Almost 2/3 of the way. Okay. I'm going to take a little bit of this leftover grease here. Redistribute that. I should have made a key mark on it. I don't know that it. Not that it makes a difference. One of the things that we did in this rebuild, build, is the hub was originally held together with Phillips head screws, so we exchanged those for internal wrenching screws to hopefully give a little bit more friendly removal and replacement if this ever has to come back apart again in the future. And you can see that it's drying down as that Permatex, the gasket sealer. Okay. And actually, since I've got so much, I put too much Permatex in there and I've got so much oozing out, I am just going to use that as my Loctite rather than, I mean, to be candid with you, with all the surface area of a flathead countersink bolt on there, that really acts as a sort of a its own locking. And that one's a little bit dry in there, so I'm going to just put a dab on there. Okay, just for giggles. This was the one I started with, right? I think so.
Do you want to wipe off the fingertips?
Exactly.
Here's some paper.
Oh, thank you. Well, at least it's not anti-seize because I would be silver by now. Alrighty, so this was that trick. And then your secret was just to hold it and then spin the axle, right? Or spin.
Well, no, I used the, well, that, but I also used the needle nose.
Right.
Yeah.
That was the trick, to
Right.
hold it with a needle nose and then. See if I can get it down a little bit further with my fingers. Okay, well, that's moving that, so it's, I'm going to say that, I'm going to call that snug.
Yeah. You got another nut on that side too. At the end of the wire.
So I need to do similar on this side.